Okay, asymptotes. Lots to do here. Let's do the horizontal first because it's less work. Horizontal asymptotes are when the limit as x goes to negative infinity or infinity equals L, where L is a value, not like infinity or negative infinity. So here we go. Here's the limit as x goes to negative infinity. So try to evaluate this limit directly, and you should note that we get infinity over infinity. So that's indeterminate form. And we have two options here. Actually, like three I can think of to solve this. So we can go back to 2.6 and we had a theorem, shortcut theorem here. Or we had some work where we'd multiply by 1 over x squared on the top and bottom. Or we can use what now? L'Hopital's rule. Now L'Hopital's rule is probably one of the easier ones, and since it reviews what we talked about on Friday, I think it's a good approach for those reasons, but maybe the shortcut theorem would be even easier. And what would you get? Those of you that are thinking about that. 2. You would just take 2x squared over x squared simplifies to 2, done. That's a shortcut there. But so anyway, I'm going to, L'Hopital's is almost as short, but I just want to demonstrate that. So now we can take the derivative of the top and get 4x, derivative of the bottom and get 2x, and that equals 2. So it's pretty short either way. So what we can conclude already is that x equals 2, or just kidding, not x, that y equals 2 is a horizontal asymptote. So it might be tempting right now to stop and say, hey, I'm done with horizontal asymptotes because I found one. But you do want to check the other scenario when limit as x goes to infinity. Our goal is not only to get the asymptote equations here, it's also to get information like what we found in the first one. X goes to negative infinity implies y goes to 2. I'll just write it in shorthand like that. And I'm going to box that off because I need to draw what the graph is doing as x goes to negative infinity. It's going to go to 2. And so, yeah, we have a horizontal asymptote there, but it could be either from x goes to infinity or negative infinity. So we need that more specific information too. Anywho, let's go to this limit as x goes to infinity. We get infinity over infinity, and actually because of the x squared business on the top and the bottom, this is pretty much exactly like the last one. The limit's 2. So we also need to draw as x goes to infinity that the graph is going to 2 as well. So in a sense, it's kind of like a double horizontal asymptote. We got two things making it a horizontal asymptote. So questions on the horizontal asymptotes? Okay, we've got about a page of verticals. The verticals are kind of a pain for this one. So the tip I gave you in the guidelines was to see where you had division by 0, and we pretty much did that in the domain. So we had division by 0 at x equals negative 2 and x equals 2, right? So any place you had that going on, you got to check from the left and the right. So how many limits are we going to get here? 4. 4 limits. I'm going to work from left to right because that's how we're going to want to make our graph. So the first one will be the limit as x goes to negative 2 from the left of our function. So on the top, let's see if we can be kind of lazy. If I did negative 2 instead of negative 2 from the left, what would the top be? well, what kind of 10? Negative 10. Okay, if our 2 is, negative 2 is a little lesser, a little greater, it's still going to go to negative 10. If it's negative 9.999 or negative 10.0001, it's really not going to make a difference. If it was at 0, that would make a difference because the sign would change and would change how this function is behaving overall. But because it's just going to a value that's not 0, then I can just be kind of lazy here and not do the actual left-hand limit. Now let's see in the bottom. What's going on here? Actually, I'll just tell you, you're going to have to be more careful here. So just do kind of a thought experiment. You don't actually have to plug this in, but think about negative 2.0001. That would be a value that is coming from the left of negative 2, right? Now just think about doing this operation in the denominator, squaring it. You're going to get 4.00 something, like a little bit bigger than 4, right? And then you subtract 4, and it's going to go to 0. But is that 0 going to be positive or negative? Positive. Yes. Because you're taking a value that's a little bit bigger than 4 every time, and then minusing 4 from it. So yeah, it's going to 0, but it's positive. That's what that little plus is meaning there. When you are using 0, because to the right of 0 is always positive. All right, so now we put these two things together. We got some constant that's negative on top, 0 from the right on the bottom. Like if you just had 1 over 0 from the right, it would be infinity. But because we got negative 10 on top, what is this going to be? You got to take care of the sign. So 10 divided by 0 from the right is infinity, but it's negative 10. So it's negative infinity. So we just figured out that we do have a vertical asymptote, at least one, at x equals negative 2. But we need to retain that original information when we make the graph, that as x goes to negative 2, excuse me, from the left, then y is going to negative infinity. 3 more to go. Questions on that one? So now we're going to the right of negative 2, and we're going to play our game again. Now note that the top is going to be the same because it's at negative 2. I can be sloppy, just have that go to negative 10. No issues. From the right, for the denominator, let's think about a value that would satisfy that. That would be like negative 1.999. So if I plug that in to x squared, I'm going to get something very close to 4, but is it greater or less than 4? Less than. So when I subtract 4, it's going to go to 0, but it's always negative. So now we play the game. We have negative 10 divided by something go to 0, that's always negative. A negative divided by a negative is a. So this reduces to a constant positive number divided by something going from 0 to the right, actually. So what is that? Infinity. So we need this information when we draw our graph. Negative 2 from the right implies that our y is going to infinity. Now because this function's even, we could actually just do half of these limits, but I want to write down all the information, just kind of go through these quickly. Again, I'm assuming that in this work you're not actually using the symmetry, we'll just kind of use it as a check. So let's do 2 from the left. The same thing happens on the top, it goes to negative 10. And the x value for this, to kind of think about it, would be 1.999, for example. The bottom is going to 0, but because 1.99999 squared is less than 4, we get something going to 0. That's always negative. So here we have this limit being identical pretty much to the last one, and we get infinity. So I can note here that I also have a vertical asymptote where at x equals 2, that would be implied by the symmetry, but we just kind of did that from scratch there. And then I'm going to put that extra information that as x goes to 2 from the left, then y goes to infinity. One more to go. Limit as x goes to 2 from the right. On the top goes to -10. On the bottom, this is like having x being about 2.001. To kind of think about it, it's going to 0 from the right. Limit overall is -infinity. So as x goes to 2 from the right, y is going to -infinity. Questions? Alrighty. The next thing we have to do is increasing and decreasing stuff. This is just like 4.3.